Okay, so alright, here we go. 6.5, law of cosines. So, here we go. Law of cosines is, and these are long formulas that you're going to need to remember, but they do have a nice little pattern that you can follow. Notice how this is side A that we're solving for, and with side A, notice how cosine has alpha matching it at the end. Okay? Then the other pattern. Notice how it's b squared, c squared, and notice how it's bc in order there. So basically you have yourself like a Pythagorean theorem up in the front, minus 2 with whatever these two letters are, right in a row afterwards, and cosine of whatever's in the end. Well, it happens the same way this way. Since it's b, b's in the end, then it's a squared, c squared, so that's why it's minus 2ac. And then the last one is c squared, which means that's why gamma is on the end. So it's a squared, b squared, and then once again notice why it's minus 2ab. Okay? So try your best to remember those formulas. With law of cosines, it's normally used when you have three sides. That's the key time to use it because you can't really find a solution otherwise because you don't have any angles. So examples, triangle ABC, you're given A, B, and a side. This is another time that it's appropriate to use because it's side angle side and side side side. They're basically the two main times to use these. So you have the two sides, which we have, no problem. We have our two sides and we have the angle in between. So the side, how do you know which one to solve for? Well, since you have the two sides and you have the angle, the only thing that would be left that you don't know is b. So in this circumstance, you're probably going to use the b squared formula because that's what you don't know. So it's b squared equals 5 squared plus 8 squared minus 2 times 5 times 8 times cosine of 77. So that's a 25, a 64, and a negative 80. And you combine that all together, graduate on that side, so you get b squared is approximately 71.0039. You square root both sides, and you get that b is about 8.43. So now that you know enough sides, and you have that angle, law of cosines is good to find the sides, but I would now use the law of sines to find the rest. Don't keep using law of cosines. Law of cosines can get rather tedious and rather boring. So my point is you use it when you have to find whatever side or angle is missing. And then afterwards, go back to law of sines because that's the easier formula. So because we don't know gamma or alpha, basically it's sine of alpha over 5 equals sine of 77 over 8.43, which equals sine of gamma over 8. And because we know both of those, now we can just cross multiply to find whatever's left. So I guess we're going to solve for gamma here first. Sine of 77 times 8 equals sine of gamma times 8.43. So I divide by 8 on both sides. Divide by 8.43 on both sides to get sine of gamma equals 0.92467. So I just do the inverse signs. I'm trying to find the angle. Sine of negative 1 of 0.92467 to get 67.62 degrees. And because we did that, now I can find the other missing angle because all I do is I know a triangle has 180 degrees, so I do 180 minus 67.62 minus 77 equals 35.35, and there's all your missing angles and sides. So example 2, you have a triangle and you know all three sides, but you don't know any angles. So it doesn't matter which formula you use. Honestly, it doesn't matter which one of those three law of cosines you use. I normally just use the first one because it's the one that I try to remember the most. So I plug in everything. I have a 90 squared equals 70 squared plus 40 squared minus 2 times 70 times 40 times cosine of alpha. So 90 squared is 8100, 70 squared is 4900, 40 squared is 1600, That is all negative 5600 times cosine of alpha. You can combine those together to get 6500. So I minus the 6500, because I'm trying to solve for cosine here. I divide by a negative 5600. Figure out that cosine of alpha equals 1600 over negative 56, but you just do inverse of that. Inverse of cosine, because it just works like inverse of sine. When you're trying to find the angle, you have to do the inverse, negative 1. So you end up getting 106.602 as that angle side. And once again, because we have at least one angle now we can do the other angles using law of sines easily and perfectly fine. So when we're doing this one now, let's take a gander here. We go and fill this all in. I know sine of 106.602 over 90 equals sine of beta over 70, which equals sine of gamma over 40. So I need to find one of those missing angles, so I'm just going to do the one right beside it. So sine of 106.602 times 70 equals 90 times sine of beta. To get sine by itself, I divide by 90. And when I do that, I get 0.74535, but to find the angle, remember you do the inverse, so it's sine of negative 1 of 0.74535. So I get 48.2 as my answer for B. And once again, because you know two angles, you just do 180 minus 106.602 minus 48.2 to find the last missing angle, which is 25.2 degrees. Alright, so when we come back here, I will keep going with law of cosines with example 3.